I wanted to talk about it's a bit of like a retrospective that I want to take about using reactive programming and specifically RxJava on Android for a number of years now in our production application. And I've talked about RxJava before, and there's like plenty of material now on the web as well that you can look at if you're unfamiliar with the library. And I kind of want to, while this is about RxJava, I want to focus a little bit less on the library itself and kind of what gaps it closes in the Android framework for us, and focus a bit more about how we use it in our application and how it has impacted the way we write software for our Android application, and kind of the patterns that emerge as well, the problems that we ran into, and kind of hopefully this give you like some insight into how we solved these problems. So it's going to be a bit opinionated, of course, but I hope it's still going to be valuable, even if you haven't used RxJava before, just as kind of like a motivation. So that said, I actually had to remind myself how long we had been using RxJava for. So I dug a little bit through the archives, and I found this commit, which is from 2013, March. So we've been using it for about 2.5 years now, and as you can see, we started using a pre-release version of RxJava. So it has been like a bit of a wild ride since then, and it was like before API stability and before the main release was out, like long before the main release was out. So of course we bumped like into like a few issues in the beginning with RxJava, but in hindsight, like it has a massive impact on our application, and it was, I think everyone is super happy with the choice. So that said, what I want to present going forward is a little bit like walking down the stack in our application and highlight a few things that I thought were interesting talking about in terms of how we split up our code, for instance. So let's start with looking a little bit how we compose our application. So in terms of layers, for instance, and what constitutes to a particular layer. This is kind of like looking again at like 2013. So like about 2 years ago, 2.5 years ago, we were following like a pretty like standard run-of-the-mill like layered approach to our application architecture. So you would have, like at the very top, you would have your presentation objects like views and your Android fragments and whatnot. You would have your business objects somewhere in the middle, like acting as like mediators into like kind of delivering data from the data layer up into the presentation layer. And at the very bottom, we would have our data objects, which would talk to the service API, talk to local storage, and so forth. So nothing really like terribly interesting there. What did happen like later that year though was that, and this mostly happened in the backend at SoundCloud, was that we kind of came to realize this kind of platform-driven approach that we were taking didn't work very well anymore. So we were pretty much like all focused around technology. So we had like Android teams, we had an Android team, we had an iOS team, we had like a web team looking after the platform as well. And this didn't align well with the emphasis that we wanted to put on particular features that drive business value. So we actually moved to a model where we would split up our organization around features rather than around technology. And this is really to then drive the technology and our software that we write into a direction that would more accurately resemble what we want to deliver in terms of value. And we had started doing this in the backend already, and it is a transition, so it took a while for us to go through this. And mobile was last in this transition, so we were like still a platform team until a few months ago. But we did see this coming. So what we realized what we would have to do going forward was to work more towards a model that looks a little bit more like this. So it's kind of like a matrix organization where you still kind of want to have the separation between your layers. You want to still have your presentation objects kind of separate from data, of course. But also we wanted to have a little bit like cleaner vertical lines in the application, which means if you would think about such things as our discovery features, like exploring new content or search, in contrast to things like our timeline features, which are more like on Twitter, if you're unfamiliar with our product, where you discover new content by following people, and it kind of is this endless stream of tracks and playlists that you can look at. So we wanted to separate our code along those lines as well. And then an interesting question that comes up is, how do you communicate, like, A, between the layers, so in this vertical direction, how do you transport data from the data layer through your business logic into the UI at the end of the day? And also, now that we have this other axis that we introduced, how do you communicate between features, right? So without compromising on, things like, you want a particular piece, like a particular element of this like feature matrix, you want it to be still cohesive and kind of decoupled from the rest of the system, so that you don't end up with this like big ball of mud, as it's sometimes called, where everything knows about everything else. And I mentioned this because I think this is where RxJava really helped us a lot. And Android kind of leaves you alone a little bit. Like there is a number of mechanisms in Android for to have components communicate in your application. Think of intents, for instance. Intents are a very common way to communicate. Or handler message, for instance. Often it's just like callbacks between objects that you have, but it's a bit of a mess, and it's kind of like difficult to get right, especially if you think about that these edges, like where we transition between features or where we transition between layers, they often involve concurrency, right? So we have to jump off the main UI thread to do something expensive like fetching a JSON response, for instance. And then the question comes up, what is like a good approach to handle with these without solving the same problem over and over again? What I want to do going forward is I want to take one of these vertical slices as kind of like a guide through most of the presentation, and show you for like a particular feature how we've done this, particularly using RxJava. And the feature I picked is the sound stream. I already mentioned it. Why did I do this? Well, because right now it's our landing screen, so it's one of the most prominent screens in the application. You see it when you first open it. I think it's like, for me, it was this is like such a typical screen to implement, because at the end of the day, it's just a list of stuff. And like if you have been written mobile applications, I'm pretty sure you've written like screens like this before, which are lists of stuff, right? Whether it's cards or grids of things, whatever, it's the same problem. And another interesting thing about this is it looks simple, right? It's just a list of things, but there's actually quite a fair amount of complexity in here. If you think about things such as, this is an endless stream of items, right? If you follow people, there will be new content, maybe on a minute basis or hourly basis. So it's like a stream of items. And so this could grow very long. So you need to start thinking about lazy data delivery, such as paging, right? So you scroll to the bottom of the page, and then you want to lazily fetch new content in. There are things such as pull to refresh. You might be looking at like an outdated version of the screen, and pull to refresh is a very common paradigm for a user to refresh content. So you have pull to refresh. There are things such as error states. So what if it goes wrong? Like if you fail loading the next page, you have to think about all these error views that you need to manage now. There might be retry logic, right? If you want to retry fetching a page because maybe it failed loading, you have to deal with this as well. So what I'm saying is, while it looks simple, there's actually a fair amount of complexity, and I'm pretty sure I'm not the only one who has written pretty nasty code in the past, like making all this stuff come together. And I just think that RxJava was really helpful in making this a little shinier. So if we take a closer look at what constitutes this vertical slice, there are certain types of objects that we found at each level, of course. So at the very top, which is, and by the way, like you might have already noticed it, I'm using this color scheme where a green is presentation, orange is like our business logic, and purple at the bottom of the stack is data. So whenever I show code samples going forward, maybe keep that in mind. So it's trying to guide you guys a little bit through these layers. So at the very top, we have our presentation objects, and well, the first thing to mention there are like Android views and fragments. We use MVP in our applications, so our view is actually very lightweight. I'm going to show some code in a minute. And so most prominently, what we do is we have a screen presenter at the very root, at the very top, which is responsible for steering the presentation logic and talking to our business logic as well. And it will do such things as listening for Android lifecycle events, for instance, and dispatch them further down the stack as well. Next, we have what we call our feature operations. So these are, if you're familiar with a clean architecture model, these are our use case classes, or sometimes called interactors. And they contain all the business logic. So they're basically responsible for wiring up multiple data sources and looking after things such as scheduling as well. So I mentioned already, like typically you want to jump off the main UI thread if you want to do anything expensive. So I don't think the presentation layer should be concerned with such things. So we do this on this layer. And whatever business rules you might have for like validation of models or some such. And so the link between this we established through RX Java and to some degree also RX Android. Although I have to say that we use actually very little of the Android, the RX Java, RX Android library. Mostly we use the handler thread scheduler, which allows us to actually dispatch callbacks on the Android main thread. So we mostly use it downstream, so where data propagates from like the server or the data source in general to the presentation layer. And underneath would be our data layer, which contains all the data that's relevant for a particular feature. This could be for our sound stream in particular. This would be like a local database into which we sync content regularly. And of course, like the service API from which we originally like fetch this data. So pretty straightforward. And yeah, so there can be multiple of those involved to back up a certain feature. And I think one thing I want to highlight here is that there's a single edge from the business logic into the UI. And I think this is really important because what we want is the UI should be really dumb, right? It should not really have to like juggle a lot of different objects to kind of pull for some data over here, pull for some data over there, and then maybe execute a logic in between. This makes our views very complicated, and views are difficult to test. Most of you probably know that. So I think this like dumb view approach is a healthy one. So because then you can push the logic further down the stack where it's easier to test. So if we look at how a view looks like, I picked out, we treat fragments as views, by the way, so they don't really have like a controller aspect to it. I know some people prefer like MVC, and so they would look at activities or fragments as controllers. For us, they're just basically vehicles to kind of like the glue between the framework and the pieces of code that make up our app. So we try to separate everything out. So this is, of course, like a distilled fragment of code, but actually for this particular screen I was showing, the fragment is about 50 lines of code. So this is how lean our fragments are. There's almost nothing in there, it's just wiring. And one thing I want to highlight here is this little piece here. So when we inject the presenter, who is responsible for steering these views and talking to the business logic, what we do is we use a library called Lightcycle, which is something we built in-house. And basically what it does is, it's actually not built on RxJava. Like it's one of those places where we used a different technology to address the problem. But what it does is it basically dispatches lifecycle events that we get from Android to any number of collaborators in a fragment. So this could be a presenter, it could be multiple presenters. You can also nest light cycles. It could do things like view tracking if you want to do something like this. It could really be anything. And we retain our fragments so that they maintain a state that we inject, which is kind of like a cheap and like way to make sure that you don't lose out on any data that you might be fetching in the background while the screen goes through a rotation change or something like that. So if we look at Lightcycle a little bit closer, the way it works is you would have a companion object called a dispatcher in your fragment. And the fragment can be the dispatcher itself as well if you choose to do it that way. And what would happen is if the fragment receives a callback from the system, such as onCreate, it would simply listen for this event and automatically forward it to any other light cycles that you inject. So the nice thing about this is if you have, like in this example, you have 3 light cycles injected into a fragment, they don't know each other. So it's very nice to have like a cohesive bit of functionality, put it in a single class, but it will expose the same API as a fragment, right? So and it works for activities as well, by the way. So it's quite nice because then we can test them in isolation. So any of these things can have their own unit tests, and we just rely on Lightcycle as kind of the mediator between the framework and our classes to do the wiring, and we just assume it works. So we don't write unit tests for fragments at all. We only write unit tests for light cycles and any of the logic underneath. Okay, let's look a little bit closer at presenters. So this is the presenter, the screen presenter that we use to render the sound stream. And it's about, I think in total it's about 200 lines of code, so it's not tiny, but it's also not massive. Essentially what all these screens do, if they render a list of things, is we go through a binding step. So this is not quite your data binding, what you from MVVM, and Android has the data binding library now as well. So this is something we did well before then. But what a binding is essentially the step that connects an observable sequence that we built with RxJava to the UI. And it's like it's kind of like reusable infrastructure code. We do this on many screens, not just on this one. So the thing that sticks out here is this collection binding that we create, and the way it works is Lightcycle would dispatch a callback to our presenter, such as, oh, like this view has just been created. Please, go and fetch data for this view. And it does so by talking to the stream operations, which is the use case class for this presenter, which exposes an observable sequence, in this case, which are our sound stream items. And then we can tell it, load this into this adapter using this builder syntax. And we can also do such things as, here is also a paging function, which is an Rx function, and I'm going to talk about this in more detail on the next slide, actually, to perform paging logic. So that's really all they do. And of course, like the other direction works as well. So so the presenter would listen for things such as click events. So if we have a button in your views, it could attach itself or an internal subscriber to a click event, and then talk to the business logic to do whatever it's supposed to do. So paging, I already mentioned who here has built this before. Maybe a quick show of hands. Yeah, I mean it's such a common thing to do. Like everyone has to deal with this problem, and I've went through like a few implementations of this in the past, and I thought they were like a bit difficult to struggle, because if you think about this, it's very much, it's like one of these problems that sits between the layers, I would say, because there's a lot of view-specific logic involved, of course, because it has to do with scroll events, updating the UI, but there's also logic involved that needs to make a decision from how, given a particular page, how do I arrive at the next page, right? So this could be something like traversing an HTTP link to like the next page of JSON elements that you fetch from in the network, for instance. It could go to the database as well, who knows? We actually do both in our application. So these are things you don't want to have in your views, right? You don't want your views know about how to construct like queries to fetch, to like move a database cursor around to the next page of items or something. So we were really keen on having something that is, that does not create information leaks into the views about like how we obtain this data, and also that is reusable, because like clearly the sound stream is not the only screen that we want to page. So the way it works is we've built it with Rx, of course. So we created a pager class, which is like a slight abstraction over an Rx publish subject, which is basically, you can just think of as like a channel, like an event channel. So you can stick events in like one end, and you can subscribe other listeners at the other end. And so that you can communicate in a decoupled way. And the way it works is, so the fragment would subscribe itself to the pager, and if there is already a page available, it would emit it right away, and just deliver this page back into the subscriber through an Rx or next call. And the second piece of logic that comes in here is, if you scroll to the bottom of the page, it will detect, oh, it's time to load the next page. So it will issue, we have like a reusable scroll listener, which will issue a signal to the pager called next, which will instruct it to emit the next page. So now the question is, how does it know how to load the next page? And here comes the interesting piece into place, which is an operator in Rx called switch on next. What switch on next basically does is it can, like given an existing stream of items, you can switch over multiple streams. So basically what we do is, given an initial stream of items, using switch on next, we can switch to the next page, but from the perspective of the caller that actually listens to the sequence, it looks like a single stream of items. So if you want to think about this in more like procedural ways or terms, it's basically moving around pointers, I would say, moving around pointers to lists, right? So that's kind of internally what happens. So the pager would have like a reference to what is the current stream of items and the reference to what the next stream of items is. And using switch on next, we can make sure we have like a very easy way without having to juggle any of the state ourselves. RxJava does all the heavy lifting for us here to emit pages of items into a subscriber. And in order to determine how to obtain the next page, it will ask a paging function. And if you remember from the example of the code sample of the presenter, where it asks for this paging function, it asks the business logic, give me a paging function that tells me, given a certain page of items, how do I arrive at the next one? In the case of the sound stream, it would be a database call because we sync in the data in the background. Yeah, so this is totally reusable. And basically, the only piece of information we need to provide to the pager is the paging function. And then we can just plug in this object in like every single screen we need paging on, and it just works. So moving down the stacks a little bit. So this is like an orange-colored slice of code. So this would be in our use case classes. Particularly, this is the class that is responsible for making for the data delivery into the UI. So what we wanted to do is we need like a page, like I already mentioned, which is just a list basically, right? A list of stream items. I think maybe what stands out here, what is interesting to see is it's the point where things come together, right? So if you remember like the vertical and the horizontal communication here, so first we have vertical communication. As you can see, we return an observable sequence again. So it's really just like a lazy description for the UI to subscribe to and then eventually get data delivered. And but it's also horizontal communication because as you can see, we use this zip width operator here to reach out to a totally unrelated feature that we compose into the screen, which is a Facebook invites element. So this is basically something that we load on top if you're a new user of the application, which invites you, which is a call to action to invite your friends to the platform. And the nice thing here about this is this particular class does not have to know anything about how this works, like where this data comes from or what maybe the conditions might be for when this is supposed to show up, because this this call to action actually only shows up, I believe, only the 5th time like you enter the screen, not always, and then never again. But none of this information is here, which is good because this is the sound stream it shouldn't know about. This is like a separate feature. And this is just like, I think, very symptomatic for, I think, a clean Rx architecture where you have a single stream that you compose into somewhere else and all the complexity is hidden beneath it. And scheduling, of course, so we call subscribe on here, which basically means we have a scheduler that we inject and which tells the sequence where it should execute. So, of course, this is still not like the end of the story because we need to obtain our data somehow. So again, like this use case class needs to reach out to some collaborator and ask it for data. So I already mentioned we heavily sync data for the user that is logged into the application so that we can make functionality available to the user as quickly as possible so they don't have to look at spinners all the time. And for the sound stream, this means then that in order to load a page of items, we go to the database. What we've done here is we would have like a collaborator, which we just refer to as a storage class, which abstracts away the way we talk to the database, basically. And again, like it's just like an observable sequence. So from the perspective of the caller, they have no like idea actually where it goes to. And we do not expose cursor objects or anything, so no database information leaks into a layer above. And what we employ here internally is we have a library called Propeller, which is basically, it's a light abstraction on top of Android SQLite database, and which lends itself a bit better to reactive programming because basically it looks at tables as basically collections and iterables. So it exposes iterable cursors basically so that you can use things like Guava or like any kind of standard Java collection mechanisms to deal with your data from local storage. And because of the duality principle between RxJava and iterators or observables and iterators, it's very easy to turn them into Rx observable sequences. So we have this Rx companion objects in Propeller, which can take a query that we write and it turns it into a observable sequence. And in this case, it would emit like a cursor, and then we map this cursor or this row, basically, of the table to a particular item that we want to emit. Okay, so this basically concludes the vertical way of how we do things. So that covers all the layers, but we still quite haven't answered like what we do horizontally, right? If we want to truly talk between features that maybe should not even know of each other at all. And this is, again, like a really common case I'm pretty sure like most of you in the audience had to deal with, which is this example. So we're on the sound stream again, and it's a mixed list of like tracks and playlists that other people post or repost. And so what I can do is I can interact with these, right? So if I click on a playlist here in the middle of the screen, it launches me into a totally different experience, and I can do stuff there. I can engage with it. So I click the like button, it increments a counter, and then I press the back button, and I go back to the previous screen. So then the question comes up is, you might have noticed that there's like these little stats that we keep around. And so the little heart symbol and the counter has increased like immediately, right? So it picked up the fact that I engaged with this object on a different screen. And I think the important takeaway here is that the sound stream is built by a different team. Like this is not just a technological issue, right? This is, if you move to a feature team organization, the sound stream is built by a different team than the screen that renders a playlist and where you interact with the playlist. So then it's very important that you need to make sure that you do not like couple like these things too closely to each other. So like, yeah, the basic problem basically becomes, if we look at these two screens side by side, how do we establish a communication channel between them that without these screens actually knowing about each other, we can pass around data in like an easy and efficient way. And again, like Android, like sort of has ways to do that. You know, intents are clearly like one way of doing this. But I always thought like intents are like terrible to work with because they force like a couple very odd complications on you as a developer, such as like parcelables, right? So you have to, if you put, the only way you can pass around data in an intent is by putting things in a bundle, which again needs to is restricted by this parcelable API, so you need to be able to marshal this data, even if no inter-process communication is involved. So it's super weird, because like more often than not, you do not have inter-process communication. You just go from one screen to another, but you use the same vehicle, which is intents, to communicate this fact, which I think is a very awkward design decision in Android. I guess they made it because they want to have like a single concept to like, you know, model this kind of messaging, but it makes things very complicated or unnecessarily complicated. And so the way we solve it is using Rx subjects. And of course, we still send an intent to open the activity. There's no way around this, but we do not actually communicate via intents in terms of data passing or message passing. So I already briefly mentioned what a subject is. It's basically, if you know what an event bus is, like the event bus pattern, it's basically that. So it's just like a single event queue, and you can, you know, post things on the queue, and either there are subscribers or there are no subscribers. If there are subscribers, they will get the message. If there are no subscribers, they won't get the message. So this is what we did, basically. So here's the use case class for this particular screen, or more specifically, the engagement bar that we have there for to trigger a like. So in order to toggle a like, what we need to do is we need to persist this fact to the database. So we use commands or command classes that know how to persist a certain change set to the database. And we turn this into an Rx observable sequence. And what we then do is, if this is successful, we use the map operator to turn this into something that we can publish throughout the application. So we can say, oh, hey, this worked. OK, good. So now we want like other screens who might be interested in this fact know about it. So we use the map operator to turn this into a change set, and then we publish this change set to the application. Well, how does publishing work? It's simply an Rx action which gets the data passed in. And you can see here we use like this event bus.publish call. It's really just an Rx subject in disguise. Like it's nothing fancy. So if you remove all the fluff, you would have an Rx subject. But we found it a bit easier to work with, instead of working with like a dozen different subjects that we inject like in all these like different screens, we found it a bit easier to have like a light abstraction around it, and that we called by a common name, event bus, and that we inject as a singleton throughout the application. And we have a test double for this as well, so it's actually really easy to write unit tests for these things, because we can fake events on the event bus and make sure that other components in the application receive the right events, or subscribe themselves or unsubscribe themselves from the event bus. So don't worry too much about property set here. That's it's kind of like a common data format that we use to pass around change sets in the application. It's basically just a data bag, but it's similar to a map, but it's type safe over its keys. So it's like a nice way for us to stuff all sorts of data in there, turn it into a value object that we can create events from, for instance, and move it through the application using Rx observables. And well, on the receiving side, there was the sending side. On the receiving side, so here we are in the view layer again. We need to pick this up, right? So we need to make sure we receive this event, and then so that the views can update themselves accordingly. So here we we simply subscribe to the same event queue and simply update the adapter. So if we get this change set, it's as simple as updating the specific item in the list and rendering the list. So that's all we need to do, and we're done. Yeah, this concludes kind of my walk through how we implement like a particular feature. But of course, there were like certain things that came up over and over again that we wanted to look at again. I think it's just like maybe general advice about like how we do certain things in our application. So one thing that comes up over and over again is how do you deal with connecting observable sequences to views, specifically of fragments and activities. We chose the most simple way, which is to just bind subscriptions to the lifecycle callbacks we get from Android. So we would have something like subscriptions that follow the view lifecycle by subscribing sequences in a call to onView created, and unsubscribing when we get the onDestroy view callback. This leads to a bit more boilerplate than other solutions. There's like more clever solutions out there that go all in terms of Rx, and then they model. They basically emit every callback you get from Android as a separate Rx event through an observable. I found this gets very complicated and a bit difficult to understand. So I think this is a very straightforward way of doing it. So this is something you would find a lot in our code base. Another thing that comes up over and over again is what I call fastpath or lazy update, which is concat first. So what you often want to do is something like, if I have a value cached already, I want to emit it as quickly as possible, right, to the UI, so that my UI is responsive and everything. But maybe I don't. So maybe I need to go to the network after all and fetch it, because maybe it isn't cached. So here you can use the concat first approach, which is basically using the concatenate operator in Rx, which just appends two sequences to each other. And the way it works is either the first one completes right away and doesn't emit anything, then it proceeds to the next sequence, which would be fetching it from the API, for instance. Or because of first that we add at the end, if it does emit, so it did emit a value from the cache, then first we'll simply take this singular item and unsubscribe. So it would never even get to the remote call. So this is a really common pattern that you can use to implement these kind of like cache and then fetch approach. You can also omit first, then you have kind of like a lazy update, which means you omit something from your cache, so the views immediately get the item, but it will then also fetch an updated version of it and emit it again. So then you would, for instance, see a number pop in, maybe with a second delay or so, which updates itself. So it's very simple and very nice way. It's kind of the reactive version of get or else, right? Observable transformers are like a super nice thing as well. So they use the compose operator. And basically what they allow you to do is take any number of composition steps in a sequence and turn them into a single one. So to make this more concrete, what you could do is, instead of always saying subscribe on this background thread and observe on the Android main thread, you could take these two calls and declare a transformer that always performs them for you. And then you can compose instances of this transformer, for instance, here like a high priority UI task, whatever if that's the thing you want to do. composed into your observables. And a nice thing about this is it's great for testing, because if you unit test this like scheduled model sequence there that you expose, you can just swap this out in a unit test, and you can do run it like synchronously on the current thread. So you remove all concurrency in your unit test, which makes it super easy to deal with threading concerns. We also have deferred execution that we use quite a bit, especially in Propeller, like the data layer. So here's something you would maybe want to do if it's just like an imaginary sequence of integers. It's just like an example to to explain the point. Let's say you have a function that computes a list of integers and it's expensive, so you want to put it on a background thread. So essentially you want to delay this call until someone actually subscribes to look at this data. And it's an iterable because it's a list, so commonly what you would do is you would create your observable and then walk over the results of this computation and emit the results into your subscriber. However, there's like a number of problems with this code. First of all, it doesn't handle errors very well, so it might throw, like computation might throw, so you might want to catch errors and forward them to the subscriber. It also doesn't deal with back pressure, and I'm going to talk about back pressure briefly. So what I recommend doing instead is just reuse RxJava operators to do all this heavy lifting for you. There's an operator called defer, which is basically allows you to pass a lambda, which is an observable factory. So, and it's only executed when someone subscribes to the sequence, not before. So if someone comes and subscribe, you can actually pass this result of your computation directly into a factory method called from, which turns any Java collection into a observable sequence. So it's a single line, and it's more resilient because you reuse all the infrastructure that RxJava gives you to deal with things like back pressure. A few common pitfalls I wanted to talk about as well that kind of struck us a few times. And yeah, if you use RxJava, maybe this might be interesting for you as well. First of all, there's a really tempting overload of the subscribe call on a sequence, which takes no arguments. I do not use this because it has it has the following problem that you might not be aware of. It relies on the fact that you basically that you'd never receive an error, because since you do not provide this call with an error handler, what it will do if you get an error, it will rethrow a fatal exception basically and crash your application. So even if you want to do like a fire and forget style call and you're not actually interested in the result, make sure you always subscribe to sequences and have error handling logic present. Otherwise, this might bite you, in production and suddenly crash your application. Another thing that is specific to the observe on operator to receive notifications on a different thread is this particular interesting case. So we have a subscriber here, or an observable, and we immediately emit a value. Doesn't matter what it is, and then we fail. So we call on error with an exception. So what you would expect is that the subscriber on the main thread would get the value first and then the error. But this is actually not what happens. And the reason is that onNext gets actually dropped because onError always cuts ahead of onNext. So if observe on recognizes that your sequence has failed, it doesn't even bother emitting any other items anymore, because it wants subscribers to know as soon as possible that something went wrong so that they can detach themselves, for instance. So yeah, so this can lead to surprising behavior if you debug something and you don't get your values emitted. So something to be aware of. Back pressure is like, it's a big topic, so I'm not going to get into too much detail, but so maybe I'll just mention it here, that it can cause problems. Basically, and this might be surprising, this is some code I took. You don't have to read or understand it, but this is code from the observe on operator as well. And the one thing I want to highlight here is this request call, because basically RxJava internally isn't actually based on a push model. It's based on what they call reactive pull, which basically tries to address the case where a subscriber is too slow to process all the notifications that a very fast observable emits into the subscriber. And so basically what happens instead is internally, when you don't see this from the outside, it requests a specific amount of items. And but if the observer, the consumer basically, doesn't process them fast enough and doesn't ask for the next batch of items fast enough, what happens is that it will fail putting the new items that are produced into the queue. And the surprising thing maybe is on Android, heads up, this is 16. So this is the internal buffer size, and clearly you can quickly run out of 16 items that are cached internally if your subscriber is a bit slow. And basically then it will throw missing back pressure exception, we will crash your application. So yeah, something to be aware of. To deal with this, a pretty obvious way is you can simply take load of your target thread and make sure that you don't overload, especially the main looper on Android. All the draw calls on Android go through the main looper, so we did the mistake that we were a bit defensive, and all our callbacks we would schedule whatever it was on the main thread. It's very easy, like observe on main thread, and then you're done because you don't have to deal with concurrency anymore. But of course, like this comes at a cost, because then if you overload the main thread and the main looper too much, at some point, like your sources will emit faster than Android is able to catch up, like processing all these messages, and then you run into these issues. Of course, you can also buffer your sequences using things like toList or the buffer operator, so they can cache them and emit them in bigger chunks. And there's built-in back pressure operators, which I'm not going to get into, but you can just look at the documentation there. And there's also a system property, which is a bit the hackier approach, that you can actually override this value of 16 if this is something you want to do. If you think, maybe 64 or whatever magic number is like a better choice for your application, you can bump up this internal buffer size. Okay, I'm almost done. I want to super briefly cover the topic of debugging. I suppose there's something to be said about, what does all this mean? Is it super difficult to understand if something goes wrong? The good news is, there's only a certain class of issues that I've found I usually end up debugging, which is something like, messages not arriving in subscribers or something. RxJava is really it's very, very solid. So it was a while until I really found a bug in RxJava. So if we take this little example sequence where we just emit a bunch of numbers and turn them into strings, so there's a mapping step involved, and then there's observe on, how can we debug this? How can we possibly log this? You can use the debugger, of course. That might be, with all these back pressure stuff internally, if you look at observe on, it gets a bit difficult to understand. So we wanted to make this a bit easier to work with. So what we ended up doing is we wrote a small library called Gandalf, which is basically a annotation-driven bytecode injector. So it's based actually on project by Jake Wharton called Hugo, which initially was meant to only inject logging into your application. But I think we just took it to its logical conclusions and added all sorts of annotations for debugging and tracing. So we don't only use it for logging, but we use it as well to inject all sorts of other instrumentation into the application. It does this with AspectJ. If you're familiar with this, it is a bytecode injector. It can, for cross-cutting concerns, so it can generate bytecode for you and inject it into all kinds of different points in your application. And then we would have two annotations that we can use to output logging. So it looks a little bit like this. I have an observable factory. This is the example I was showing earlier. And the only thing we have to do is apply the Gandalf plugin to our Gradle build scripts and then add this annotation, rxlog observable. And we can do the same thing with a subscriber, but I'm just going to show it here for the observable. And what you will get is this. It will simply print the sequence it observed to the command line. So here you can see in this particular class, which is main activity, this is not from our application, it's just a dummy application. And this particular method called create observable, we subscribed on the main thread, and then first we received the value 1, then 2, then 3, and so forth. Then we completed and terminated, and it took such and such amount of time. And then you can see there's an unsubscribe call at the end as well. This can be useful, as I mentioned earlier, when you want to debug a sequence where somewhere along the line it dropped the message and you're not really sure where it happened. Then it's kind of nice to see, oh, it unsubscribed after this and this step, and then you kind of, it's like a lead into where you can start looking for problems. Maybe I should briefly mention there is an official component as well called RxJava Debug, written by Netflix for the pre-release version of RxJava. It doesn't look to be maintained though, and it's actually based on a pre-release version of RxJava Core. So I don't know what happened to that project. It works in a different way. It uses the plugin API of RxJava and has very noisy output. So we decided to write our own thing, and yeah, going forward. This pretty much concludes my talk. So if you want to stay in touch, this is my Twitter handle. And before we go into the question, just a reminder again, please rate the session and submit any last minute questions, I guess. Thank you.
Okay, yeah, now it's unmuted. Thank you very much, Matthias. There's a couple of questions for you. One is about the RX propeller. Could you compare that to the SQL Brite by Square?
Yes. Yeah, great question. I should say we're working on open sourcing this project, by the way, but it fell a little bit behind schedule. We've been using it in production for about 2 years now, so it's actually not a new project. And it started out as a simple abstraction layer on top of Android SQLite, but we added, as our application grew with RxJava as well, we added these like reactive functionality to it. It differs from SQL Brite in the sense that I actually think it's a bit more powerful, a bit more complete as like a fully functional query builder. So I think we covered pretty much all the cases that there are. What we do not do, what SQL Brite does is SQL Brite basically you can register a query with an observable, and it's basically like a table observable. So whenever then the table changes, it will re-execute this query and communicate the result back to you. This is something that we don't actually support right now, but we're working on this. Yeah, like other than that, it's really like a totally unrelated effort. So we started on working on a while ago. If you're familiar with Yahoo, actually put out, and I actually forgot what it's called, but Yahoo put out a library as well for dealing with SQLite databases on Android. I think Propeller compares a little bit more to Yahoo's library. Just Google it. I don't remember what the name was, but yeah. Okay.
Thank you. And one final question. You probably saw this coming. Lightcycle.
Yeah.
Open sourcing.
Yes, we're working on it. It's like it's a very simple library as well. It's an annotation processor that basically, through a single binding step, allows you to like hook in all these different classes, and it's really not much. Like it works similar to Dagger in the sense that it generates source code, which is the binding companion basically to your light cycle, which is then instrumented through this like binding step. So yeah, like again, like we definitely want to open source this. It's just right now it's a question of time, like and priorities and stuff. But I hope we get to this like maybe this year still. Yeah.
Okay, so
otherwise, like if you can also come to me and I can show you a little bit like how it works.
Okay, but thank you very much, and please give him a hand.
Thanks, Sam.